Okay, now we're going to do something a bit different. In previous lessons, I've shown you examples of bytes of data in memory, and I've written out for you what those bytes might actually be. So in this lesson, we're going to actually create a program that is capable of displaying the contents of memory as actual binary. And we can do that using everything that we've learned up until now. Now, I'm not going to claim that this is the best or the most efficient way of doing this, but the purpose of this lesson is to show you that using what you've learned up until now, you can do this. So let's begin. We're going to start out with a basic skeleton program. And now let's start with a byte of data. We're going to use the char data type because we're looking at an individual byte, and we'll say my character equals lowercase a. So what we want is a printf function that will basically print the actual binary here. We can even make it put a space. So how do we do that? Well, first of all, we need a way to check each bit. So let's test the first bit. If my character and here's our bit mask because we're testing the first bit. Now if I wanted to, I could make that hexadecimal, but let's just keep it binary just to really make this lesson clear. Now what are we saying here? Let's go ahead and break this down. Since we're doing the AND operation here, my character, which is lowercase a, is going to look like this. And when we do an AND operation on it, what we get is going to be this. Now specifically, if this bit had been set, we would have gotten this. So a 0 result will indicate that the bit we are testing is not set. So a 1 result, or a non-zero result rather, will indicate that the bit is set. So if that's the case, we'll go ahead and printf a 1 because the bit is set, and if not, we'll print a 0. So how do we do that? Well, let's write one more if statement here, except this time we're going to say if it is equal to 0, then we'll printf a 0. Okay, great. So that takes care of a single bit. We can test the first bit like that. Now later I'll show you a better way of doing this than two if statements, but for right now, for illustrative purposes, here's how we do that. So let's go ahead and run the program, and we'll be able to see if the first bit is printed properly. And we'll take out this unnecessary printf statement. So if we run this, and you see that the very first bit is 0, and that worked correctly. Now all we have to do is repeat this process for 8 bits. Now there's several ways to do this, but what we're going to do just for this lesson is we're going to just cut and paste it for each bit. Bit 3, bit 4. At the end of bit 4, we'll go ahead and put a space because we like our binary to be properly formatted. Now we're going to continue. Bit 5, oops, bit 6, bit 7, and last, bit 8. Now we just have to change the bits that we're testing. So for the first bit, we're obviously testing this. So for the second bit, we're going to test the second bit. So the first bit is going to become a 0, and the second bit is going to become a 1. For the third bit, now the fourth bit, the fifth bit, 6th, 7th, and last, the 8th bit. Okay, so let's go ahead and run this program. And you see that we have printed every binary digit for the letter A, the lowercase letter A. Now if we change this, let's suppose that we set this character to the text character 3. Then we know that the result should be this. Let's see if we're right. And there you go. Now there are more efficient ways to do this, which involve a lot less code. But this is an example for you, just to see that even with what you've learned so far, you can do this. So I hope you enjoyed this lesson, and the next lesson is going to be the last lesson of Unit 12, which is lesson 12.8, and then we will go on to Unit 13.